Hi, my name is Ronit Langer, and I'm from Teaneck, New Jersey, and next year I'm going to MIT to study computer science and electrical engineering. I've been swimming competitively since I was 5 years old, and I'm a certified lifeguard and swim instructor. And over the years, I've used my love of science to help me understand my swimming better and to improve the swimming of me and my students. So what we're going to talk about today is the physics of swimming. The goal of swimming is to move as quickly as you can along the x-axis of the water. Now, the biggest obstacle to your forward motion in the water is a force called drag. Drag can be described by this equation over here. Drag is equal to 1/2 the viscosity of the fluid times the density of that fluid times the surface area of the object exposed to the drag times the velocity of the object squared. Now, it makes sense to me that when I'm walking through the air, I can move pretty freely. But we know that the second I walk into water, I feel this resistance. So let's get some numbers to try to understand why this happens. So we take the first half of this equation, the viscosity and the density. Viscosity is the property of a liquid that causes it to resist the force of flowing, otherwise known in common language as thickness. The viscosity of air is 1.8 times 10 to the -5 Pascal seconds, which is a very small number, whereas the viscosity of water is 1 times 10 to the -3 Pascal seconds. Now the next term in our equation, density equals mass over volume, which means the more mass you have in the less amount of space, the denser it is. So the density of air, we have mass in a very large volume, so it's 1.2 kilograms per meter cubed, but the density of water is so much greater. It's 1,000 kilograms per meter square. So when we take the viscosity times the density of air, we get 2.2 times 10 to the -4. And when we take the viscosity times the density of water, we get 10, which is a 48,000% increase from air to water. So you have to be fighting a lot of drag when you're in the water, and that's something that a swimmer has absolutely no control over. There's an interesting question that has been plaguing physicists for years. Do you actually swim slower when you swim in syrup versus in water? So at first you might say, of course, because the viscosity of syrup is so much greater than the viscosity of water. But the interesting thing is that because it's so much more viscous, when you pull your arm back, you're moving a lot more liquid. Therefore, you're getting a lot more forward force. So therefore, you can swim equally as fast in syrup and as in water. So I hope this video helps you no matter what liquid you're swimming in.